Hey guys, so for today's lesson we're going to be talking about multiplying polynomials, and this is something that showed up on the pre-assessment, and not very many people remembered exactly how to do it, although I think it's probably something that maybe you've seen before. Um, some teachers call this double distribute. Some choose to call it FOIL. So if you know how to do any of these, another one is box method. If you know how to do either double distribute or FOIL, and you can do that correctly every time, then by all means go ahead and do that. The method that I'm going to teach you though is box method, and that's just because this connection from polynomials to geometry is going to be super important for us, and that's a higher level of conceptual understanding that I want for you to get. Essentially, box method just comes from the idea of area equaling the length times the width. Okay? And if you wanted to use box method, for example, for a distribution problem, something super simple, let's say 3 times x plus 5. Essentially that means that you can make a rectangle, make a box, call one side of it 3, call the other side 3x, or I'm sorry, x, and then plus 5. And then you're essentially finding the area of each little small rectangle. So this one would be 3 times x, that's just 3x, and this one would be 3 times 5, and that's 15. So then you could just know that your total area, or the distribution there, would be 3x plus 15. Okay? Using a model, we can apply this to multiplying binomials, like the ones I wrote at the top. So I'll rewrite that problem. Move the camera. Okay, so at the top we were looking at 3x plus 5 times x minus 3. Okay, and again, if you already know how to do this and you have your own method and it works, you can get the right answer, then by all means go for it. But if I'm doing the box method, essentially I'm just going to draw a box, and depending on what types of polynomials I'm multiplying, I'm going to divide the box as such. So here I have a binomial 2 terms times a binomial 2 terms. So I'm going to split the length and the width into 2 and 2. And then I'm just going to assign, right, one side to be the first term, the other side to be the second term. It doesn't matter which one I use. So I'm just going to use this first term as the top. So I'm going to split those terms up to 3x above this first column, and then positive 5 there. And then at the bottom, I'm going to say, okay, the first row is going to be x. Second row is going to be negative 3 because it's minus 3. Right? And then I'm just going to go and find the area of each little individual box. So this one is x times 3x. That's 3x squared. This one is 5 times x. That's just 5x. This is negative 3 times 3x. That would be negative 9x, and this is negative 3 times 5, and that's negative 15. To find the area of the whole thing, we could just add up all of these. So that would be like 3x squared plus 5x minus 9x minus 15. We see that these are like terms, so we can combine them, and our final product would be 3x squared minus 4x minus 15. All right? And that is how we'd multiply binomials. Again, if you have your own method, by all means, do your thing. But I like to think about box method. It's really important to me that we're able to connect the idea of area to multiplying polynomials, because then you could apply this to, for example, multiplying a binomial with a trinomial, and to things like interior design, which we'll talk about in our project for this unit.